Okay, so today we're going to be talking about how to write the equation of a trigonometric function when you are given the graph. This is sort of the last step in our puzzle here. We've talked about graphing from the equation, and we've talked about writing equations and graphing using the transformations, and now here we are, and we've been given the graph, and we need to figure out what the function is. Because sine and cosine graphs are periodic and they repeat, they also sort of look like each other, right? If you let them go on forever, like in this first example here, it's not obvious if we're working with a sine or if we're working with a cosine graph because we've got multiple cycles here. So the very first step that I want you to do is I want you to decide which function you're working with between sine and cosine. And you're going to determine this by figuring out which one has the least horizontal shift. Okay, which one is closest to beginning at the y-axis? That's the one you are going to pick. And my strong suggestion to you is to highlight one cycle of the function, okay? Even if you are not somebody who usually marks up your paper, I really suggest that you do. I just find it helps to sort of concentrate your effort when you really know what you're paying attention to. So let's take a look here. I'm going to see if I can find my two options. I can clearly see a cosine graph starting at the top and then coming down. But that one has got a pretty big shift to the left because it's starting all the way over here. So in fact, my cosine with the least amount of shift actually would probably be the next cycle, which would be here. Because now this only has a shift of 3 pi by 2. Whereas if I were to start here, the shift left is at 5 pi by 2. So that's going to be our cosine option. Our sine option always starts in the middle. And so our sine option might look like this. And then overlap with the cosine there a little bit. Or actually, I'm seeing now, so we've got a 3 pi by 2. That's our horizontal shift. But I could actually just start it right here at pi by 2 instead. And that would be our least horizontal shift. And the graph is cut off. We do not have the entire cycle, but that's okay. We can determine everything that we need to determine using the graph that we were given. So this is a sine graph. It's got the least horizontal shift. Cosine would have had a shift of 3 pi by 6, whereas sine only has a shift of pi by 2. I'm going to erase the cosine now because that is not helpful. And we are just left with our sine function. Okay, good. So we've determined its sine. That's the one that's got the least horizontal shift. Now we need to figure out all of our different pieces of information. Recall that we need to fill in f of x is a sine k x minus d plus h. So I need to figure out my a, my k, my d, and my h values. It doesn't really matter what order you do them in. All that really matters is that you find them. So what I'm just going to make note of here is a couple pieces of information. I can see that I have a max value of 3. That's the highest that my graph goes is 3. And I see I have a min value of -1. Now, our midline, aka our vertical shift, are located exactly halfway between the max and the min. So if you can't figure out halfway between 3 and -1, we're going to just do this. We're going to take the average of them. We're going to add 3 and -1 divided by 2. That'll be 2 over 2, which is just 1. And you may have been able to get there on your own without needing to do that average, and that is a-okay. So our midline here is located at 1. I'm just going to write a y equals 1 there. For our midline, we know that the midline is the same number as h, so I can say confidently now that my h value is 1. Now, from here, now that we've got our midline on our graph, we can see the amplitude pretty easily. Recall that amplitude is the distance from the midline up to the max, or the distance from the midline down to the min. My midline is at 1, my max is at 3, so the distance between 3 and 1 is 2. My amplitude is 2. And I'm going to show my math there. I'm going to say my max was 3, my midline is 1, my amplitude is 2. Just going to move this stuff up. So my A value is 2. In terms of a horizontal shift, we've already sort of talked about that when we were deciding which function it was going to be. I can see that my function starts here at pi over 2. That is the beginning of my function, and so I do have a horizontal shift of pi by 2. It's to the right, and so I am going to keep it as a minus sign at the end of the day. And then last but not least is figuring out the period. We need to, or the k value. And we're going to figure out we need to figure out what the period is in order to figure out what the k value is. So let's do that first. I'm just going to highlight one cycle of this graph. So as much as our sine function that we're writing the equation for, as much as it starts here, I can use any cycle of the graph to figure out what my period actually is. So I'm going to use actually this cycle that I'm highlighting in blue here to figure out what my period is. So my period is how much is between 5 over 2, 5 pi by 2, and negative 3 pi by 2. What is that distance? And this again might be something that you can come up with in your head. Showing the math is always a good idea. 5 pi by 2 take away 3 pi by 2 is 8 pi by 2, or 4 pi. It takes 4 pi for me to go from one start of the cycle to one end of the cycle. And it doesn't, as I said, that cycle is going to change. The period being 4 pi does not change regardless of where we sort of figured it out. And now recall that I can determine my, my k value. Okay, and I'm just going to move this up here. And these over. There we go. My period is 2 pi divided by k. In this case, I have a period of 4, that's a 2, 4 pi. K will be equal to 2 pi over 4 pi, which is 1 over 2. Okay, it's working at half time. It's moving at half the speed, and that makes sense because it's, at the end of the day, taking double time in order to get there. So our k value is going to be 1 over 2. We can now write our final function using all of our values. I'm going to do it over here in purple. Our final function, our transformed function here, is 2 sine of 1 over 2 x minus pi over 2 all plus 1. Alrighty, not bad. Let's do another one. New function here, we've got a new graph. Obviously, it looks a little bit faster. All right, first things first is we need to figure out if we are dealing with a sine or if we are dealing with a cosine function. I can see here that if I were to do a cosine function, this might be an option. Let's highlight that properly. It's got a pretty minimal shift. of just pi by 4 off from the 0. That's the only shift that's happening there. Sine looks like it might be starting, oh, I don't know, from the 0, from the -1, something like that. Maybe a little bit higher. Regardless, it looks like there's a bigger shift when I try to do sine that way. Even if I were to try to go backwards and do one with like a horizontal shift, at the end of the day, pi by 4 looks like it's going to be the smallest horizontal shift that we have to deal with. And so I'm going to keep it that way. So I'm going to write out the 4 letters that I'm looking for. I'm looking for A, D, K, and H. We've actually already said what our K value is once again. We've got, sorry, I messed up my D and my K there. A, K, D, and H. We've already talked about the horizontal shift being right here at pi by 4. I know that that value is pi by 4 because it's halfway between 0 and pi over 2. So my horizontal shift is pi by 4. And it's to the right, so my D value is positive. Okay, let's figure out now, we've got a max and a min that we've got to deal with. Our maximum value here is 2.5. And our minimum value is going to be -3.5. Whew. So where's our midline going to be? Midline is going to be halfway between the two, so I add them. Divide by 2. 2.5 plus -3.5 is -1 over 2. So our midline is located at -0.5. I'm going to add that into our graph here. Midline is the same as the h value, so our h value is -1 over 2. We can find our amplitude now. By going, what is our maximum? And I'll write that as a proper fraction. Its max is 5 over 2. Take away our midline, which is -1 over 2. This leaves me with 6 over 2 or 3. So our amplitude is 3. Our function starts where it's supposed to start. This isn't something that I mentioned previously, but there is no flip or anything happening here. This is a positive cosine function with the u, so our amplitude is going to remain positive. And then last but not least, we have to figure out our k value, our period here. So my function starts at pi by 4, and it's going to end here, which is at 2 pi plus pi by 4. So if we count up by pi by 4s, this is 1 pi by 4, 2 pi by 4s, 3, 4, 5, 6, 7, 8, 9 pi by 4. So I start at 9 pi by 4. Take away pi by 4, because that's where I'm starting. So I should say I end at 9 pi by 4. I start at pi by 4. So I'm going to go end minus start, and I'm left with 8 pi by 4, which is 2 pi. 2 pi is your normal period. We are working at the exact same value here, or the exact same speed that we are in our typical function. So I don't actually have to do anything for a k value here. I'm just going to write 1, but we know at the end of the day that's not going to appear on a function. So I can write my transformed function now. F of x is equal to 3 cosine. I'm not going to write my k value, there's no point, but I will go x minus pi by 4 minus 1 over 2. And that's that, folks. So just to recap, once again, we sort of filled in everything we could in terms of a max, a mid, a min. We determined the midline, and then from there we were able to find the amplitude. The horizontal shift was pretty easy because we were already thinking about that and determining which function we had. And then really the only sort of tricky part was the period. You just had to figure out where it ended, where it started, what was the difference between the two, and then use that to determine your K value. All right, great work, everybody.